Hi, my name is Emily Barfield, and today I'll be presenting the findings from my research on the formation of the Prairie Pothole region in the northern Midwest, its destruction due to agriculture, and the impact this has had on local ecosystems as well as water resources. But first, some geologic background. The Canadian Shield is the oldest exposed rock in the Midwest and is the Precambrian foundation on which everything else is built. About 1.1 billion years ago, the mid-continental rift expanded the area between modern-day Kansas and Lake Superior, dropping igneous deposits for approximately 20 million years before sinking and filling with an interior seaway. Collision with the European plate during the Ordovician built the tectonic mountains roughly where the modern Appalachians are today, allowing thousands of feet of additional marine sediment to fill the Midwest basins. This lithified into the Devonian limestone bedrock that exists throughout much of the region. The Mesozoic saw the retreat of the interior seaway from the Midwest and the formation of Pangaea, which set the Midwest close to its current geographical position. The start of the Quaternary period marked the beginning of an interglacial period in which multiple cycles of glacial advance and retreat occurred, scouring and recycling the ancient landscape with each turn, forming the Mississippi drainage basin and providing the grounds vital for prairie development through the deposition of carbonate till. The retreat of the Laurentide ice sheet during the last glacial maximum marked the end of glaciation in the Midwest, and thus began the development of prairie ecosystems. These grassland habitats would prove vital for water resources as the complex fibrous root system trapped soil and its contents in, giving the region an overall high water storativity. Apart from roots, however, glacial processes led to the formation of kettle hole wetlands, bringing me to the topic of this presentation. The Prairie Pothole region, also called the Glaciated Prairie or PPR, is a kettle-hole outwash plain that extends throughout the northern Midwest states of Iowa, Minnesota, and the Dakotas, and up into Canada. It's a wetland prairie ecosystem that covers large portions of both mixed grass prairie to the west and tall grass prairie to the east. And while the PPR overlaps these two grassland ecosystems, its status officially as a wetland is attributed by the characteristics left behind by glacial processes. The glacial geomorphology of this region is like that of other pothole regions, Poland and northern Germany, for example, all of which exhibit the same outwash plain existing on flat topography bounded by a series of end moraines. The development of kettle holes is relatively well established within the field, though the way in which dead ice is deposited can change depending on location. In current glaciated regions like Iceland or Chile, this can involve Yakullip events, resulting in an outwash flood that deposits dead ice on an outwash plain. The PPR, however, follows a more classic example in which the retreating glacier leaves behind blocks of dead ice that are then buried either in an end moraine or by glacial till in the outwash plain. This till tends to deposit in low hummocky topography and exhibits low permeability, sealing the ice blocks in a watertight layer that limits the intrusion or removal of fluid. This low permeability sediment is also deposited on the surfaces around the ice blocks, making the ground in general resistant to water infiltration. Over the course of about 10 to 20 years, these buried ice blocks melt and leave behind depressions in the ground that fill with precipitation and form large fields of small ponds. The impermeable sediment that buried the ice lines the bottom of these ponds, giving them the ability to catch and hold water without it seeping into the ground. In addition, it prohibits the flow of groundwater into the potholes, meaning that most of the water in the ponds comes from either precipitation or spill from upland potholes. When uphill potholes become full with precipitation, the excess water spills out the top, turns to surface runoff that can't be absorbed by the ground, and instead continues to flow downhill, filling downslope potholes along the way. This sheety surface flow, termed pothole connectivity, is irregular and near impossible to predict, as flow behavior is random and very much nonlinear. It is, however, a characteristic trait of the PPR wetland system and proves vital for long-term survival of the wetland and the natural services it provides. But how do we know that it's vital for wetland survival? Could it be that humans realize that ecosystem destruction for the sake of capital gain might yield negative long-term effects and therefore the region should be protected? The answer, no. A lot of these connections have been destroyed with the influx of modern agriculture. While the American Corn Belt has traditionally been located within the central Midwestern states, a new trend shows that higher demand for corn used in ethanol production has given farmers incentive to expand their crops further west, even though planting conditions are far from ideal. The wetland soil is actually too wet for the fruitful yield of cash crops like corn and soybeans. In addition to this, pothole depressions pose a nuisance to farmers who can't move heavy farm equipment on the topography. The answer to these problems historically has been to drain and consolidate wetlands into one condensed lake and then filling empty depressions in with surrounding sediment. This does a couple of things. One, it breaks up the impermeable soil and mixes it with soil layers underneath, increasing water infiltration and adding to a general rise in base flow. And two, draining potholes disrupts pothole connectivity and the fill and spill of water by elongating distances between potholes and causing them to become increasingly isolated. In general, modern agriculture has resulted in the destruction of 95% of the glaciated prairie in Iowa, 75% in Minnesota and the Dakotas, in addition to eradicating 98% of the tallgrass prairie in surrounding states. Here's a map I annotated to show the extent of all three prairies, in addition to the prairie pothole region. The prairies are distinguished by a precipitation gradient, with the easternmost tallgrass prairie being the wettest and most biologically dense. The PPR is outlined in dark blue, and you can see the path of the glacier and where it once was. The very end exhibits two lobes that extend throughout much of Iowa and at least are partially responsible for the fertility of Iowan soil. Major rivers are traced in light blue, with the main artery being the Mississippi River traced in teal. The extent of the drainage basin is outlined in red, and the fat pink splotch in the bottom map represents the most productive extent of the Corn Belt. In general, the destruction of the prairie and wetland regions has contributed to an overall rise in base flow seen across the entire Mississippi drainage basin. Both ecosystems are attributed to having high water storativity in both saturated and drought conditions. However, agriculture strips the land of this ability by damaging the soil's structure and depleting its organic carbon stock. As a result, excess water that would otherwise be held in situ by kettle holes or prairie roots instead travels to neighboring rivers and streams. Multiply that by the thousands of rivers within the affected region, and there's no doubt about this contributing to downslope flooding in southern communities, especially ones at the base of the Mississippi River, where all this compounded excess water drains out. Combining this with the fact that climate change is fueling hurricanes and storm surges, it spells tragedy for many people. In the very least, increasing ground saturation from inland sources dampens the soil's ability to take on water from additional sources, let alone storms like Katrina and Hurricane Harvey. On a local scale, the destruction of the glaciated prairie has resulted in a 50% drop in wildlife populations throughout the PPR. Considering the PPR is the breeding ground for approximately 75% of the North American duck population, this 50% drop is mostly made up of migratory birds like ducks and other grassland bird species. So how can we fix it? Are the damages caused by agriculture reversible in the slightest? Is there hope for the future of prairie ecosystems? The answer? Well, kinda. Prairie restoration has been underway since the 60s, yet some researchers argue that soil erosion and depletion are so severe that they can never be restored to the functionality they once had. Pothole wetlands are especially difficult to restore, as the complex hydrology is still poorly understood and near impossible to replicate. Therefore, an estimated 75 to 80% of pothole wetland restorations fail due to structural issues, and most only choose to focus on surface level vegetation restoration and fail to reestablish pothole connectivity. Further research on reestablishing the natural hydrologic regime are underway. However, no restoration method has been proposed with any resounding success. And that kind of sucks, but on a brighter side, grassland prairie ecosystems are easier to restore, though many challenges still exist. The literature suggests planting restorations next to fragmented remnants as being the most effective mode of restoration going forward. This provides seed stock for the restoration in addition to giving remnant prairies a protective barrier from invasive species. This method is being implemented by private organizations and government-funded groups to reconnect native prairie fragments. However, new socio-ecologic movements urging people to bring the prairie to their own backyards have been underway for quite some time. Landscaping with local wildflowers instead of grass puts less stress on natural resources, improves the soil, and also benefits pollinator species. That being said, if given the opportunity, I implore everyone to ditch the turf grass and plant a prairie. Thank you for coming to my TED Talk.